Okay, this is a regular 650 nanometer red laser and plain filtered tap water. You can't really see the beam. You see some of the reflection coming off the other side of the glass. If you look carefully, the beam is there, especially reflecting off of particulate matter. This is the same laser, but I am shining it through vodka, dry fly vodka to be exact. Again, you can see the beam a little bit as particulate matter, but not really. Mostly you're seeing reflections. And then this is the same thing again, but we're shining it through tea. Now you can really start to see the beam because there's a lot more particulate matter in the tea. Specifically, this is black tea. And so that's pretty exciting. Wow, actually that one's pretty boring. But now let's go with a green laser of similar power, shining it through tap water. Again, don't confuse the beam with its refracted partner, but you can very easily see the beam in the tap water. You can see the particulate matter floating around in there. This is a, let me read it just to make sure I get it correct. I remember I looked up what this was. Oh, 532 nanometer. 532 nanometer. All right, here it is in the vodka. You can see the beam again. I have a little less vodka in there than water, so it's a little harder to get the beam to be viewable. And here it is through the tea. That green color is really, really very green. And if we look again at the red, you can also see the red is just it's definitely red, definitely green, reflecting off of the particulates. Okay, here we go with the blue laser. This one is 405 nanometers. Can you see the beam there at all? I don't see the beam at all. Okay, and let's do it through the vodka. Green. It's a blue laser. If we look at it, it's definitely blue. But as we shine it through the vodka, it fluoresces, and so what we end up seeing is a green beam instead. And a similar thing happens with the tea. In fact, it attenuates quickly in the tea. It attenuates quickly in the tea. If I go right up to the very top, you can get it. Watch it going all the way across. But it's not really doing very much. Again, we see some of that green color because it's fluorescing. Okay, here's the experiment I really wanted to run, which is that I have a medicine dropper with some tea in it, and all right, are you able to see the beam there? Let me try to get the beam and the refracted side different from each other. There, they're at different angles. Okay, now we're going to put a drop of tea, hopefully right into the beam. If I have my angles correct. And you can see that tea continuing to fluoresce as it spreads out throughout the water. As I move the beam around, you can see where the tea is, even though we can't see the tea at all in the water. It's just one drop. There it is. You can follow that shape around. Awesome. So cool. Let's do it again. See all those swirly shapes? It's a little swirly right there at the end. Those really bright blue bits are probably just dust in the water. Yeah, there's one there. What I'm talking about are they look like fog almost, or that fake fog they pump into theaters for things. Another one. Ooh, now it's all purple. Well, that's all I really wanted to show you. Oh, hey, let's try one more thing. I have an idea. This is going to be a completely clean experiment here. Alright, let's see if we can tell a difference between the... I don't know. Well, now my water's all murky with stuff. That's probably actually the alcohol I dropped in there being dispersed out really well at this point. Because alcohol dissolves quite well in tea. That's my experiment for today. Bye.